Let's now take a look at how we can create our own custom bandpass filter and custom notch filter just using a low pass filter and a high pass filter using interesting signal routing options. Alright, so I have my basic patch already set up. Oscillator going to the low pass filter, going to the VCA. Alright, I still have the spectrum analyzer, but it's not hooked up yet. Let's unlock the patch and load in a high pass filter. So I'm going to go to the filters category and we have one called HPF. It's a high pass filter. Now I'm going to add the high pass filter into the signal path after the low pass filter. So let's make room for this. It doesn't matter if the high pass filter comes first in the signal path or the low pass filter, we'll still get that same result. In this case, it's going to be the band pass filter effect. Alright, so I'll lock the patch. Actually, let me unlock it and let's hook up the spectrum analyzer. Let's first hook it up to the output of the low pass filter. Alright, so you can already see that we're cutting out some of those high frequencies. So if I lock the patch, let's adjust that filter frequency and you can see in real time the movement there. Alright, so we're first cutting out all these high frequencies or attenuating them to a certain amount and keeping all the lower frequencies. Then we're cutting out low frequencies or attenuating low frequencies. Let's put the analyzer over here now. I'm going to set these to specific numbers. Let's set this to 5000 Hertz. So frequencies above 5000 Hertz are being attenuated. And on the high pass filter, I'm going to set this to 1000 Hertz. So now frequencies below 1000 Hertz are being attenuated. They're not completely getting cut off because that's how filters work. They have a slope parameter and you can see here the slope is not that steep at all. In fact, the low pass filter at 24 dB per octave seems to have a stronger slope there. All right, but the bottom line is we have now created a bandpass filter. So the thin sound is because we've cut out all the low frequencies as well as cut out all the high frequencies. Let's try a different range. I'll set this to 1000 and I'll set this to 500 Hertz. So we have a narrower range there. And that's still a bandpass filter. So you get to adjust the higher point and the lower point. On a standard bandpass filter, you typically don't get to do that. All right, now let's switch this up to a notch filter. So for the notch filter, we just have to change the signal routing using both filters. So I'm going to unlock the patch. I'm going to disconnect this cable here. I'll move this over to the right over here because we want this oscillator signal to be duplicated and sent to the high pass filter. And then we want the combined signal to go into the VCA. Now in this software domain of Max and BEAP, we can actually connect multiple cables into an input like this. But in the real world, you won't be able to do that. So I would recommend using a mixer. So we have a mixer category here. Let's load in the audio mixer. It has 3 inputs. So I will disconnect this cable, plug this into the first input, disconnect this cable, plug this into the second input, and plug the output into the VCA. All right, so we should get the same result. Let me first increase the volume of the second input here. So now we're hearing the signal of the low pass filter going to the output. You can see activity here already. And then we're also simultaneously hearing the signal of the high pass filter on the second input here to the VCA. All right, I'm going to unlock the patch one more time and plug the output of the audio mixer into the spectrum analyzer and delete this cable. Now you notice that we're still seeing the spectrum. That's because the signal is not being attenuated here. It is being attenuated here at the output of the VCA. So let's plug this cable down here. All right, so now we don't see any signal, but we will see the signal once I play notes on the keyboard. All right, so what's happening here? Let's set this to specific numbers. Let's set the low pass filter to 1000 Hertz. All right, so on input 1 on the audio mixer, we have frequencies 1000 Hertz and below. And then simultaneously on input 2, let's set this to 3000 Hertz. So that's the high pass filter. So we're keeping frequencies above 3000 Hertz in here. So what we're missing is the frequencies from 1000 Hertz to 3000 Hertz. So that is our notch. Let's see this. It's a bit hard to see, but there is a bit of a dip over here. And that's essentially the notch. Now, the reason why the dip is not so obvious is because we have very smooth roll-offs. If our filtering was a bit sharper, there would be a very obvious hole in the center there. I could kind of accentuate it by adding some resonance on both filters. And let's try it again. Yeah, now you can kind of see that dip a little bit more obviously. Alright, so that's how you can create a bandpass filter as well as a notch filter just using low-pass filter and high-pass filter.